Welcome back to the second session of the simplex method. The previous class we were looking at how to create a model, and we created a model. Now we go into the intricacies of the simplex method itself. Okay, what do we do? What is the first step we undertake when we are working out the simplex method linear programming problem? Okay, first we introduce what we call a slack variable or slack variables. Okay, how do we define slack variables? Mathematical representation of surplus resources are what are basically known as slack variables. Okay, just a mathematical representation of surplus. I'll give you an example. If you are a baker and you want to bake a cake for business, basically you have your measurements of oil, of butter, of baking powder, is it yeast, whatever ingredients that you're using. Those ingredients are what we are calling variables. Okay, based off the your different variables or your ingredients to make this cake, you realize that when you are actually done creating the dough or making the dough and putting the whole thing in the oven, there will be some leftover flour, there will be some leftover oil, there will be some leftover yeast. You had intended that you use all these things to bake this cake, but in real sense, usually there are these leftovers, and basically these leftovers are what we are calling slack variables. They are what are called slack variables. Okay, now when you're dealing with an equation or an equation like this particular one, where you have 4x1 plus 3x2 is less than or equal to 240. What this equation is implying that whatever 4x plus 3 x2 is, you're going to use either exactly these or these particular combination of variables are going to consume the entire 240 on the right hand side, or you are actually going to use something that is less than 240. Okay, if 240 are the total hours you're going to spend creating tables and chairs, this equation is saying that when you're creating chairs and tables, you might not use the whole 240, or you might exhaust it. Okay, now in the event that you haven't used all of those particular variables, that portion that is a leftover is what you are going to term a slack variable, the unused number of hours. Okay, so for the first equation, which is 4x1 plus 3x2 is less than or equal to 240, we are going to introduce a slack variable to indicate that there is a possibility of a leftover. So we are going to say 4x1 plus 3x2 plus s1. S is going to be a representation of a slack variable. Now, when you introduce a slack variable, this particular sign will change from an inequality sign to an equal sign, 240. Okay, so the same will apply for the second equation. So you have 2x1 plus x2. We introduce a slack variable. Now, since this is a different equation, we are going to say s2 is equal to 100. Okay, having introduced these two, we go to the objective function. The objective function, the interest is not to introduce a slack variable, as it is not an equation that is telling you of the usage. It's about the profits. Okay, so what do you do to the objective function? You bring everything that is on the right hand side, you take them to the left hand side. So you know that on the left hand side you have z max. Okay, z function there, you have that. So if on the left side you have z, Max, and you decide to bring these two on the other side, when they cross the equal sign, they become negative, aren't they? Or they change the sign. So that is 70. When it crosses the equal sign, it becomes negative 70, x1. And the 50, when it crosses the equal sign, it becomes negative 50, x2. Giving you a 0 figure on the other side. You have nothing remaining there. Okay, so we have done the first stage. Okay, introducing the slack and moving the variables that are on the right to the left. Okay, that's the first stage. Second stage, you create a model of a table, which we call tableau. Okay, where you are going to create your initial feasible solution. Okay, so this table will have 3 segments. Okay, this will have 3 segments. Okay, I am going to call, right, let me put an extension to this one. So this is going to be basic variables, and this right hand side or side. Okay, so in the middle, you put all the variables that are here, that are represented in the equations. So we have x1 being represented there, you have x2 being represented, you have s1 being represented, you have s2 being represented, then you also have the z, Max. Okay, then on the horizontal, or I mean on the vertical side, you put the slack variables s1 and s2. Okay, then you start saying, what is the value of, in the first equation, what is the value of x1? It's 4. What is the value of x2 in the first equation? It is 3. What is the value of s1? It is 1. The value of s2 in the first equation, there's no s2, so meaning it is 0. You don't have any z on the first equation, meaning that one will be 0. What is on the other side of the equation? On the right hand side, you have 240. You go to the second equation. You do the same thing that you have done there. And then you go to your objective function, which you put down there, the z function. Okay, we have negative 70, right? Negative 70, negative 50. You don't have any slack s1, you don't have any s2, but you have the z, which is 1. You have nothing there. Okay, you have created the initial feasible region or solution. Okay, now we go to the second stage or the third stage. So this is the second stage where you've created the table, you've inputted the values in the table. Okay, then you begin identifying. You identify the most negative. Identify the most negative in your z function. Okay, you have negative 70, we have negative 50 and 0, 0 and 1. What is the most negative number? It is 70. Then go vertically upward and circle everything that is in the vertical column, which creates this column here, and we're going to call this column as pivot column. Okay, then these digits or these figures that are in the pivot column, you're going to divide them into what is on the right hand side. So the 4 is going to be divided into the 240, and the 2 is going to be divided into the 100, giving us 60 here and a 50 there, right? Okay, having divided, you identify the smallest positive number amongst your divided figures here, these particular results. The smallest positive number is 50. It is still positive. It has to be positive. but it has also to be the smallest. So you have 50 as the smallest positive number. Now, this one, which is the smallest, you circle this particular row having the smallest positive number, creating your pivot row. Okay, then after identifying the pivot row, you look at the intersection. Which number is in the intersection of your pivot column and your pivot row? So you realize that this particular two that I've put a star on here is both in the column and in the pivot row. This becomes your, it becomes your what? Your pivot number. You may call it your key pivot or your pivot number. Okay. Okay. Now, after identifying your pivot number, okay, after identifying your pivot number, you divide the pivot number into your pivot row, everything in your pivot row. Okay, what are we talking about now? Okay, so here we see that the pivot row has been divided by the pivot number, which is 2. So you divide everything that is in the pivot row by 2, which is a pivot key or pivot number. So you divide by 2. Then you create another tableau. Okay, let's create another tableau. Okay, so basically that is what you end up having. So here we are saying in this particular column, you after dividing 2 divided by 2, you are getting 1, which is this one. 1 divided by 2, it remains as a fraction. 0 divided by 2, that gives us 0. 1 divided by 2, it gives you a fraction. And 0 divided by 2, still 0. 100 divided by 2 gives you a 50. Okay, we haven't inputted the values of these others. Now, here's another key thing that you need to know. After dividing here, okay, the idea when you are dividing is that this particular key here should be equal to 1. Basically, your key number, okay, or your pivot number, or your pivot key, however you want to call it. When you identify your key number, you want it to be equal to 1. And basically, by dividing 2 divided by 2 gives you a 1. And once you have a 1 there, you want whatever that will come here and down there should be equal to 0. So you can only have 1, 1. And remember, these are, matrices, okay, where you have 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, matrices. So basically what you want, if here your key, if you've made this particular key number equal to 1, you want the digit that will come up there equal to 0, and any key that will come down there equal to 0 also. So 0 above and 0 below. Okay, but how do you do it? Okay, how do you ensure that you have a 0 up there and you have a 0 down there? That is what we are going to do in the next class.